So now let's see this now. So we had discussed about tuple yesterday. I believe it's a good session yesterday, and we understood very clearly, like in detail, about what is tuple, is it immutable or mutable, and what exactly is difference between tuple and list. And you can expect interview questions on these data structures. The people at least ask them at least some 3 or 4, like 4 to 5 interview questions there. I cannot exactly say this is the count, but this is one of the very important topic for interviews. So friends, try to understand this as much as possible, focus as much as possible on data structures. Also, this data structures is very important in the development of your applications. So without data structures, you cannot expect any real-time Python applications. So such is the importance of data structures, friends. I hope this is clear for all of you. Let me see if I'm recording or not. I need to upload Python records. Yeah, I'm in the process, friends. A lot of work is being done around this thing. We are building websites and then also YouTube channels, everything. So I'll share it. Maybe today's and yesterday's session, I'll share it by today EOD. Okay, friends. And also the remaining sessions, previous sessions, we'll try to upload as soon as possible. So let's move to the next topic today about list and tuple. That is what. See, both tuple and list are used to deal heterogeneous data. It's not like we don't need to say homogeneous because both are heterogeneous in nature. Okay, friends, it's not like both are this homogeneous is not something specific to these two. They are heterogeneous. In that process, heterogeneous means we can pass similar type of data, different types of data. So that is it. Now coming to the point of tuple comprehension, what is this? This is very important, friends. Comprehension means it's like writing multiple lines of code in just single line. That's called tuple comprehension or list comprehension. And this is widely used in a real-time application. But for this, you need to have a better understanding on this coding thing. Because if you want to simplify coding, this is one of the best thing in Python. Okay, what is comprehension here? Comprehension means it's a simple way of writing your code, just writing code, multiple lines of a code in a single line, and this is what we call comprehension. And the syntax look like this. Before you talk about comprehension, we discussed till this yesterday, and I told you we will come to a very important topic today, which is used widely in a real application in a Python development. Okay. Sorry, friends. So this is actually is tuple comprehension. What is tuple comprehension? This is the syntax. What is this? The square brackets. And in this, you have these parameters. It's more or less like simplifying your multiple lines of code into a single line. Like, comprehension means instead of having a very big paragraph, we just simplify it in just 1 or 2 sentences. That's called comprehension. Same thing here. So the syntax look like this. This is actually a list comprehension, whatever you are seeing here, the square brackets. If you see anything like square brackets and a single line of code implemented in that square brackets, it is list comprehension. Sorry. If I say tuple comprehension, just please ignore that. This is list comprehension. LC means list comprehension. TC means tuple comprehension. The only difference here is list comprehension means we apply the square brackets, but that's how we create list, right? And similarly, tuple comprehension means we apply this parenthesis. You can see here. You can see this parenthesis. Of course, syntax is almost same here. We don't see big difference here. Okay. So now what is this parameters here? Whatever the logic you want to apply, that comes in the first place. Okay, logic or that operator or operand that comes, sorry, that operand that comes here in the first place, that expression otherwise. So EXP represent expression. Expression can be a logic or that variable or that operation you want to pass it. That should be here. That is the first place. Second place is iteration. Iteration means, like, to FR loop, while loop, something like that. And third thing is a condition check. Condition means, write something like dividing something or, you just say something if some X percentile to doing some validation for even something like that. It's not like it should be only validating even, just giving a small example. Sorry, friends. Suddenly there was a network glitch for us from in this thing. Shall we continue? Let me share my screen. Can you hear me? Can you see my screen? There was a slight network glitch. I lost myself for a few couple of seconds. Am I clear? And can you see my screen? Yeah, thank you. Thanks for confirming. Okay, fine. So we are talking about this one, friends. This comprehension thing. This is the syntax, friends. What is the syntax? Expression means your logic goes here, and then iterator, a loop should come after that, and then a condition, some kind of condition check should be there here. So this is the syntax, friends, for comprehension. Okay. If it is a list, just apply square brackets. If it is double, apply this parenthesis, this round brackets, what I say. So let us try to apply this comprehension on a simple example, and let's have a quick idea about this comprehension, friends. So this is a simple program. What we are doing is just applying some powers here. We are writing a normal code here. Let's see this. If you want to just to give, implement power of some number, some I is there. So if you want to say 2 to the power of something, so you are just trying to find the power of 2 here. This is a simple logic. We are iterating from 1 to 10 or 1 to 9, and we are implementing this power of 2 here. So this is a simple logic to implement power of some number here. That is the program here. Okay, let us just test it now. So this is the program. Let's open this one, Python. It, just, I don't know why. Just a minute, friends. It's taking some time. Not sure why. Should not take this much time. Okay, I think we are good here now. So create one simple this thing, tuple collection again on this. Just a minute, friends. This is a little slow today. Not sure. Usually it won't be. Okay, create a simple tuple program. Right click and then just a minute, friends. It's okay. Let me try to. This is not actually responding much here. Okay, let me close this then. Just a minute, friends. It's taking time. Okay, I think now it should be fine. Okay. Okay. Yeah. So yeah. So we are just taking it as a comprehension. So comprehension. This is the topic, and very useful one. Because I know we keep doing this automations, right? So we see the people use a lot of this comprehension, and in that people, even I am one among them. Uh, this is very much useful, friends. Okay. So now let us come to the point here of this one. Just take this simple program. So this is a very simple program, very basic one. We are just trying to understand it with a simple example, like how this comprehension works for us. Okay. See, this is a simple one. You see now, what is this program? We are just getting the power of some number. If you put 2, you get 2 to the power of something. And if you put 3, you get some 3 to the power of something. So here up to 11, you can take up to 11 here instead of up to 10. Okay. So now, maybe if you want while printing, you can simply say, what is it? You can apply a format method and do whatever, this thing you need. So let's run this code and see the output. Okay, right click and then simply say run comprehension. Yeah, what is the error here? Put colon, friends. Don't forget colon. That is very important for us. And right click and then you can see here we created an empty list here. And what we are doing, we are trying to iterate loop from 1 to 11. And then of course it runs till 10. 11 is excluded in a range function or range method. And then it applies, it implements this logic to the power of some I. Means we are implementing power of some number. Here it is 2 to the power of something. And then we are appending that each time when we do the power, we are appending that result to the list here. And we are printing the total list here. Okay, let's run this now. So this is the output. You get all 2 to the powers from 1 to 10 here. Okay. So now same thing, if you rewrite this with comprehension, it might be a list comprehension, it might be a tuple comprehension. How would it be? It is a so simple code here. Okay, let us see that. So if you rewrite this with a comprehension, it looks like this, friends. This is tuple comprehension. And let us just take this code and analyze this and get the output. Come here. We are doing this is actually a normal code. So this is normal approach. Normal approach to implement power of some number from within a given range. So that's what this is, friends. Now, what we are doing here, another one, we are applying a comprehensive approach 2, and this is actually a much more simplified. You are not writing at least multiple lines of code here. All that we do here in multiple lines, we are just doing it in a single line here. So what is the logic here? This is 2 to the power of I is the logic. That is the we put this expression or your logic. And in the second place, we pass iterator for I in, you can see here range of some 1 to 10. Every time you iterate this number, that the I, that I is a power is applied on this I, 2 to the power actually. This one is applied on I here. So you can see here, this time, of course, condition is optional. We only use two parameters. One, the expression or logic. Two, the iterator here. If you want, you can apply a condition as well. Okay, if maybe we'll Google it and take few more examples if needed. Not a problem, but giving a quick idea. So this is what comprehension is, and it can be even if you put this like this. If you put like this, the square brackets, this becomes what, friends? This becomes a list comprehension. Okay, and maybe if you print it, let's print it here. So print this T or some. Okay, this is the result. If you print T, this is the list comprehension, and output should be in the form of list here. All this iteration happens, and all this logic is implemented, and that result is added to a list here internally. Okay, because you are applying a list comprehension here. Maybe if you ask me a question, Manoram, how do we apply a tuple comprehension? Just change this to this parenthesis, right? We call it as parenthesis. So change it to parenthesis or this general round brackets. Then this becomes a tuple comprehension, right? So this multiple lines of code, what we write on top of this approach to, we are just simplifying this with a single line of code here. You can see here. Right, and generally this takes 3 parameters, but of course, condition is optional. If you are not taking it, means it is optional. It's not mandatory. So we implement this logic here. See here. Now run this now and see. Now execute it. You can see here when we execute it. This output is from approach one from here. Maybe if you want to go more better output, I'll just write here approach one. We are just doing it with a regular way of implementing logic. Approach two is a comprehension, this thing, comprehensive approach, approach. Okay, see this now. This is fine, but again, when you look at the output, this comprehension is returning us something here. Observe this carefully, friends. What is this here? This is a generator object. Generator means when we apply this comprehension, all that result, whatever that comes, what this list this tuple comprehension does here is it performs all that logic, and that is returned to a generator object. You can see here it is returned to a generator object. Now again, you might ask a question now. So if it is generator object, where is the output? I'm not seeing anything in that generator. So generator is more or less what is this? It's internally stores all your result in the form of some collection. Okay. What should we do now? Again, when you get a generator object or or iterator object, what should we do? We should apply some iteration on these objects. We cannot directly just see something in these objects. It's like a box with some elements, something inside that with a wrapper on top of it, like a gift box. When somebody gives you a gift, can you directly see that what is there inside it? You don't see, right? What you have to do, you have to open that gift, and you have to see that what is there inside, present in that gift box. Similarly, assume that generator is a simple gift box given to you by adding all that items into that gift box. Now, what do? When you apply comprehension, you get all that result is added to that generator object, and that is returned to us. So what shall we do now? Now T is a generator object here. See, if you ask what is T here, it is a generator object, and internally there is a list inside that. Okay, so what shall we do now? Simple, right? we have to just iterate this generator object to see the result that is present in this generator object. I hope this should be clear. What should we do? We should iterate generator object. These are all very important things for you friends. Whatever we discuss here, tomorrow when you do real coding, you have to have this idea on all these things. And whenever you see something like this, the next thing that should pop up into your mind is, okay, I got a generator object. Then let me apply an iterator to see what is there in that generator object. And applying iterator, all of you are familiar. That for thing now, by now, we have used at least some 50 to 100 times or more than that so far. So now iterate. So this returns generally what happens if you apply this. So this tuple comprehension, this is a tuple comprehension, friends. Okay. So that returns what generator object. So now, okay, I'm just adding a point here. We get a generator object when we apply a tuple comprehension. I'm just clearly writing here when we apply a tuple comprehension. Again, you might ask a question. If Manoram, if we apply this one, friends, if you apply list comprehension, then what do we see? See, but that you don't need to ask that simple question, friends. This is a simple testing, right? Just modify it to list comprehension, run it. Right click and then just test it. You can see list is giving us output, no issues. Approach one is a regular approach. We are seeing the output for that. It's just a simple code implementation. And approach two is a comprehensive approach. And say if it is a list comprehension, we are seeing same output as the first one. But the difference is this is much more simplified. Okay, with list we don't have a problem. We are seeing output as is. So list is coming out. We are getting output in the form of list itself. We don't need to apply any this thing on this. Of course, even on this list we need to apply iterator. If you want element by element, iteration will have is needed on any collection. It's not just only on tuple or something on generator object. On any collection, iteration is needed if you are implementing or manipulating data on collections. That is important, friends. Okay, so that is fine. Now we should, if it is generator, suppose if it is now tuple comprehension. So finally you got clarity, right? If it is list, at least that we are able to view the data. If it is tuple, of course, data is there where inside the generator object. Now what should you do? Apply an iterator on that. So apply an iterator and view data. Or otherwise iterator and extract data. So that is the thing we should do. Or else maybe you can ask me a question. So is there any other alternative, Manoram? Then the alternative is convert this tuple output, that generator object to iterator, sorry, list. You can convert generator to list and then again same thing. You can see the output. So that is another solution, friends. So one is when you apply list comprehension, we get generator object. Maybe if you ask me, can we direct instead of getting generator object, can we convert it to any other this observable collection? Means simply apply list here. Convert this comprehension to list here. See, pass this to the list itself directly and apply a conversion on that. Now you just try to run it before we iterate on the generator object. I'm just showing you. Another alternative approach for this is you can convert it to a this form, a normal form or something like a regular format by converting it to a list here. You can see here. Now run it. Now you can see we see the same output even we apply this tuple comprehension, friends. You can see here. So you can see the output didn't change here. We are able to see output in the form of list here, which is just a direct observable output. Okay, friends. But suppose if you don't apply this conversion, then this returns this tuple comprehension returns generator object. Then you should apply an iterator. I think I have given enough clarity on this, friends. By now everyone should be very clear on this. Okay, if it is tuple comprehension, then we get generator object. Then we cannot directly view data there. Then in that case, we should apply an iterator. By now you should be clear. Even internally you might be thinking, Manoram, we got it. Hold on, just go to the next step. Like, might be that should be your this thing in your mind. Okay. Now what do? Just apply an iterator for I in T or some element in T. You can simply say, if not I, you can take element in T and then print what element. That's all, friends. Let's run it now. Right click, run comprehension. You can see here we have iterated generator object and we got element by element from the generator object. Suppose you ask me a question, how do I know, Manoram, this is a generator object? Right? Simple, right? If you don't know what is there in T, best thing in this Python program is apply type method. Suppose you want to know, you are curious about the nature of this T. Right? You want to know what is this T, friends? Then apply what? Apply print type of T. Maybe if you want, you can add a beautiful output statement here. Now I am just simplifying it. You can apply format method and give a beautiful output there. Okay. Now when you run this, let's run this quickly. Now you can see what is this? This T is a generator object. Okay. This is one of the very important interview question. People ask a lot of interview questions. What is generator? What is decorator? There are multiple things in Python which you might expect in interviews. You can note my questions whenever I say this is an interview question. And definitely if you are just going on this in resume with Python and people asking questions in Python, this is one of the must interview questions. Generator, decorator, iterator. People ask questions on these areas. One is a generator. Second one, decorator. One more is what, friends? Decorator, one of the very important topic in Python. Then one more is iterator. You cannot expect an interview without these questions. At least people ask one of these questions in interviews. Okay, just remember, friends. Right, this is a simple idea. Got it now? So that's all about comprehensions, friends. Finally, what is the conclusion? What is comprehension? Instead of writing multiple lines of code, we can simplify that code in a single line by applying comprehension. Comprehension is nothing but it is simple approach of converting your code into a single line where it takes three parameters, a expression or this logic in the beginning and then iterator in the middle and then a condition check at the last. That's how it goes. Then the next question is okay, Manoram, this is fine for us. You gave us a simple example. We are very clear on this and it made us understand this fine. But can you give few more examples where it takes all the three parameters, like a logic, an iterator, and a condition? Then, okay, let us take one more example, friends. In such case, right, what shall we do? Let's take a quick this thing. We can say compre and examples in Python. We can say examples in Python. You can see here. You can take any of these websites, no problem. It's not like you should just only think that this is good or this is bad. Most of these are fine. Or we can simply say list comprehension or tuple comprehension that gives more better such list comprehension in Python. Okay, you can see here. Maybe you can check for these are all good actually, which is what. Just a simple example I'm just seeing here. Let us open this one, no problem. Gigs for gigs, no problem. You can see here, this is actually we did something now, just we did, okay. With just two parameters. But and what is the execution flow? Just a minute before I go into this. How this execution happens, friends. So here, what happens is this iterates. This loop iterates for one time. You can see this iterates from 1 to 10. Every time it iterates, that element I is passed to this logic and that logic is applied and that is added to that object, that respective object. Either if it is a list comprehension, it is appended to a list, and if it is a tuple comprehension, it is append that list is assigned to generator object. Sorry, this output is assigned to generator object, friends. Is that clear? So this iterates from 1 to 10. Every time it iterates this range, one value is copied to I. And each time what happens, once this iteration happens, that I is passed to this logic, and this logic is implemented on I, that is 2 to the power of I. And that result is assigned is at either to a, in this case, it is a tuple, it is that result is assigned to a generator object. If it is a list comprehension, that result is assigned to a list object. That's all, friends. Okay. So that is how the execution flow happens. And this iterate for 9 times. 9 times what happens? Every time it iterates, this logic is applied. Again, I is passed to that. And every time, each time we get some result that is assigned to this either added to this generator object or that list object, friends. So this time it is tuple comprehension. It is added, the result is added to generator object. Okay. So that's the execution flow. I hope this is clear, friends. Okay. Now, this is another example. See here, we are iterating from 1 to 11, 1 to 10, sorry. Okay. And then we are just checking. This is a simple code to get even numbers from within a range of first 11 numbers. Okay. You can see here, you can try this example again, another scenario. Okay. This is scenario. You can see this. Let's apply this. Excuse me, guys. You can just add a program for list comprehension, you can say. Without these examples, if you finish Python, means you are missing something, badly missing something in Python. Okay. Now you can see this. What is the execution flow? Maybe you can put a debugger, friends. That's the best thing. You understand it better. So this time we have all these three implemented here. We have implemented all these three parameters. Your expression means always you don't need to implement logic here, friends. It's not like you must implement logic always. Sometimes you can just add that element as is. Okay. It's not a must thing here. Logic is not a must thing. Okay, but this is a place for implementing logic. Okay, that is fine. That logic can be adding element by applying some kind of mathematical logic or business logic, or otherwise we can also add element as is like this. That is one thing. Second thing, this is an iterator. This is the place of iterator always. It can be for or while or anything. Third thing, you are applying a condition check here. How this execution flow happens here? So first this one, what happens? This iterator is executed. This then once this iteration is done, it applies a condition check on that item element. And if it is even or odd, if both this once iteration is done, condition check is done, then if this is true, then that result is added here. Is this gets executed and result is added. Else that is skipped. Adding this I is skipped if this is false here. Okay, this is the execution flow. Anyhow, let's do it. Let's test it, debug it and see it, friends. Do you get this? How the execution flow happens? Step 1, what happens? This iterator executes and that element one element is copied to I. Step 2, go to the condition check. Okay, and see if that I is even or odd. If it is an even number, then that step 3, this expression is evaluated. So step 1 is iterating, step 2 condition check, step 3 executing your expression. Here expression can be a logic or your variable or something like this. Okay. Step 3, evaluate your logic. This is the execution flow. I'm giving you a clear analysis. Step 1, this iterator is executed. Step 2, condition is verified. Step 3, expression is evaluated based on the outcome of condition. If it is true, then expression is evaluated. If it is false, this is skipped from evaluation. That is the execution flow here. Maybe if you want to debug and see what's happening here in a very deeper analysis, in a deeper approach. if you want to go a little deep into this and see, observe how this comprehension is happening, just apply a debugging point here and then right click and then debug comprehension. So run this now step by step here. So we are in the debug mode here, and you know, right, these are the options to do debug. Step over means going, you can see here, step into my code. Okay. Step out means going, coming out of that. And this is run to cursor, no need. Well, which one should we choose? We can choose either F8 or F7. So what do you do now? So we will apply this one, step into. So what's happening here? Let's continue step by step here. You can see here the output here. Even this is what's happening here. A range iterator means what this range object is enter. You can see the all variables created in the debugger window here. When you expand here, you can see all this here. Okay. Next one again, step into. You can see next again, step into. Again, just a minute. You can see here now. Every time you say step into the output, you can observe here, friends. Now, I is created, and then what is that? It's applying something. Okay, let's go on. Now you can see it's going on here. Now I is modified. Now we have I as 1 here. 1 means it checks whether 1 is even or odd here. And then based on that, what happens? If it is even, then if it is even, then it go and evaluate, execute this expression and then assign that result to some list object here, because this is a list comprehension. Okay, let's again step into. Now it has applied this. Let's apply step over then. Step over is also almost similar. Okay, it's applying. See here, every time I is iterating, I is now 4 means we are checking if it is 4 is even or odd. Let's go on. Let's go on. Let's go. You can see the output here. Now we reached still 7. It iterates till 10. 11 is excluded from this, you know, right? That is not an inclusive value for range. Step over. You can apply step over as well. Step into generally is used when you are getting into any function code. Okay, generally that is needed. Step over should work for us here. 9, 10, we reach it 10 now. So almost this is done. Iterating is done now, actually, if you see here. Now what happens, sir? Let's see. It will stop at 11 here. If it gets to that, you can see now. Once this is done, the iteration is done, and automatically what's happening here? It is doing here. Sorry, just a minute. Sorry, friends. Let's comment all this. I am just seeing here because I forgot the all this stuff. Okay, it is going and applying there. It's running there. We don't need to run there now. Let's comment all this now. Now let's run. So this is all commented, right? Please ignore whatever we have done so far. Let's run the debugging now, because the debugging is happening here. Actually, whatever we see here, that is applied for this particular code block, not for this one. I'm seeing here actually, I'm thinking this is iterating internally. Now let us do a fresh iteration. Okay, let's rerun it in debug mode. Excuse me, friends. Now run this now in debug mode. Stop and rerun. Now let us apply this. This is this thing. Okay. Now special variables are created. All this you can see here while running. And even in that main is one thing. I'll talk about main. What is main? If main exists or not, all that we discuss. Okay, leave that aside now. Now again, what shall we do now? Let's go by step here. Okay, I hope you please ignore that the tracing we did a few minutes back. Okay, now let's step over 1. Now it started with 0. You can see here now. Next step 2, 3. Okay, still it didn't. It's starting with 0 here. Okay, fine. Now next step, it moved to 1. Okay, you can see here the process happening here. Each time you can see here. Let's run it one by one. Now I is 1. Is this then after that it comes to the step 2. Step 2 what checks the condition. then is this true, false? Then it doesn't evaluate this expression here. Again, next, I is 2. Again, step 1, again, it goes to iterator. Iterator, extracted, it collected one value from range and assigned to the I. Then again goes to condition check. Step 2 is iterating again. Again, step 1 is iterating. Step 2 is condition check. So 2 percentile 2. Again, 2 is even number, right? Then this condition is true. Then this expression is evaluated. So this I, whatever I comes from here, from this, this thing iterator, that is this is assigned to the list object. Okay. So next one. Again, I is 3. 3 is again, this iterator is executed. Step 1 is done. Then step 2 condition check happens internally. If this is true, then step 3, it goes to step 3, that is expression evaluation. So, but this time 3, this is false. 3 is odd number, right? This condition is false. Then this expression is not evaluated. Again, 4, okay. This is the condition is true here. Expression gets evaluated. 5, 6, 7, 8, 9. So I hope you got the flow right. I hope you are very clear with the flow now. 9, 10, and finally execution is completed. And this whole result, once that execution is done, is appended to a list object. Okay. Now you can see here. You can see the output here. All that result is appended to the list here now in the output. You can see here, friends. Okay. And finally, execution is completed and we can see the output in the output window here. So by the time this execution list comprehension is completed, you can see this program, this print is executed and you can see the output here. All that logic implemented with comprehension, we can see in the output here. So this is simple idea, friends. This is how the execution flow happens for a list comprehension. Is that clear? I took some time here because this is one of the very important and useful, just topics in this Python, this thing, my friends. Okay. So that's why I took some time to make sure that this is clear for all of you. I believe I didn't confuse you people. Can you please confirm that in the chat box? Is this clear for all of you? Hope I tried to make sure that this iteration, this comprehension flow is clear. What is the steps we follow here? Let us quickly summarize this. Can you give me answers here, please, friends? Can you give me answers? What is the execution flow? How it starts here? What is step 1? Please answer. In this, there are 3 parameters. One is expression, second one iterator, third one condition check. Let's just have a quick analysis on the execution flow. First, what happens? Step 1. What is step 1? Let us just add this. What is step 1 here, friends? First, it tries to execute which one? This is step 1. Okay. So this executes first. Then what is step 2? Step 2 is, can you please answer in the chat box the execution flow? Step 1. What happens with step 1? Otherwise, let's add here in the comment. Step 1. We have 3 parts here, 3 parameters. What is this? Expression is one part. Let us give more. Let's get into the more deep dive into this, friends. Expression is the first part. In this place, it can be a logic, it can be a variable or anything. This is the place of expression. Step 2, place of iterator. That is, this is second parameter, iterator. And third thing, what is third one? Condition. This is the third one. This is the place of condition. This is optional. If you don't have condition, nothing happens. Sometimes if you don't see condition in these comprehensive programs, don't worry. That it might be this is an optional thing. Okay, that's all. Don't worry much about that. So condition is optional. Not every time you don't need to apply a condition. Depends on your need and necessity. You can choose condition. Okay. Condition. This is the whole comprehensive parameters. These are all the parameters inside comprehension. Now execution flow. How the execution flow happens? I'm giving you very elaborated this thing on this. Very slowly we are going. Execution flow. Which one is executed? What is step 1, friends? Let us have a very detailed analysis. Step 1 means first always it starts with the iterator. It does iteration, iterator, ITER. Okay, iterator. Step one is that it does the iteration. Then it gets an element. What based on the kind of iteration you apply, one element is copied to the dummy here. If it is while loop, it just checks condition and then moves to the next part. Then that is step one. Always iterator is executed. Step two. Step two, if condition exists, then it goes to condition check. So condition check. Step three, what? Then based on the outcome of condition. Suppose if condition is true, then it go and evaluate the expression. Else it will skip the execution of expression. So here evaluate step three expression based on condition. So this is the execution flow. Now these steps are repeated continuously. Okay, I'm trying to give you clarity as much as possible, friends. Now, after this, what happens in this comprehension? Again, these steps are executed continuously until this whole this logic is completed, executed completely. Now, again, what happens after this? Again, it go back to iterator. Again, next it moves to the next element and then apply condition check. Again, execute expression based on condition. If it is true, execute expression, else leave it. Okay, again, what happens? Again, repeat the same process. Again, go to the iterator. Again, read one element. Again, check the condition. Again, evaluate the expression. And this continues till when? This continues till your this whole execution is completed, friends. So this is simple idea about it. Might be same for list comprehension or tuple comprehension or any kind of comprehension. This is a detailed analysis about this one, friends. I hope you should be very clear on this. Is this clear to everyone, friends? I try to make this simple as much as possible for you, okay? Because this is something really important for you. That's why, I know I have to jump to dictionary, but still I try to spend some time here understanding the importance of this topic, okay? So this should be clear for you. Maybe you can try as many examples. There are so many here. You can see here on list comprehension, tuple comprehension, many more are there. You can choose not only from this website. There are many more websites. Okay, you can see programmiz.com. You can see here. You can see this is actually a general approach. You can see what we did now. After this, what they did, they applied a comprehension and then just simplified that. You can see here step two. So instead of writing a normal this thing, what they did, they just simplified with this list comprehension. Maybe in place of that, you can apply tuple comprehension. Okay, if you wish, it's up to you. Similarly, there are many more examples here. Applying lambda, we didn't still yet discuss these things. Map function or all this. It reduce function. There are a couple of functions I'll discuss in when we start functions topic. These are all very important. We'll talk about lambda and all stuff there. Okay. And you can see, you can try all this, friends. You go one by one and try to understand what's happening here with these comprehensions and try to get a hold on this topic. Okay. Now I would like to stop here because I spent enough time here. So let me jump from here and let's get into a new topic here. What is that? The very important and very powerful concept in Python is dictionaries. Because you can't imagine a code without dictionaries. Without list and dictionaries, it's very rare you see a Python code. Maybe I'm saying about a broad level, not just for simple, small logic spends. So that such is the importance of these data structures. Of course, sometimes you don't see set or sometimes you don't see tuple, but list and dictionary, they are must things like, when you go for a dinner, sometimes there are must items like that. List and dictionary are like that. Okay, fine. Now the question is, when we are starting for this very, powerful topic or very important topic, what is dictionary is the first question. Right. Before this, still, I want to ask a quick question in tuple thing. Whenever this is a quick question for you, maybe you can answer before I jump to this dictionary. I thought to ask this, but I just quickly jump into this. Whenever we implement, this is the question for you. Please answer in the chat box. Tuple comprehension. What is it, friends? Tuple comprehension. This is the important question. What is the output we get after completing this comprehension? What is the result of this operation. Okay. If you want, I can give some, this multiple choice, but I want you to answer without multiple choice for now. So what is the result we see after completing this tuple comprehension? We get same tuple object as output, or we get something else as output. So result is one is the list object. That is one answer. Second one, we get same tuple object. All that result is appended to tuple object. Third thing, generator object. And fourth thing, what is fourth thing? You can choose some ABC object or decorator object. Maybe let's apply this decorator object. What's your answer here, friends? So this is the one I just would like to ask before I jump to dictionaries. Please answer this in the chat box, friends. Okay, what's the answer here? So for this question, when we implement this tuple comprehension, what is the result of this operation? What do we get here? Please, friends, please answer in the chat box. I see only one or two responded to this. Others, friends, please let me know your answer here. What is it? I'm waiting for your answers, friends. Okay. How about others, friends? What's your answer? Is it 1, 2, or 3, or 4? The answer is definitely 3, friends. So what is the generator object? Okay, okay, fine. Now let's jump to the dictionaries. Anyhow, I'm preparing a different approach of this interview questions. I'll share that to you so you can enjoy answering that. Okay. How we are doing that? I'll reveal it in some time. Not immediately. Maybe within 1 or 2 days. You can see few things coming up. So what is dictionary here now? Let's jump to this useful topic. So dictionary means what? It's something like, usually if it is a real dictionary, how it look like, friends? You have a word and a meaning after that. It's like key and value pairs. So if it is dictionary, you see something like key and like a key and value pairs. Okay. Excuse me, friends. Okay, that's fine now. Okay, we'll come back to this again. But this is how dictionary look like. Okay, it has a word and a meaning. Word acts as a key and meaning acts as a value. Always word will be unique, but that meaning we have multiple, this meanings for that. Okay, so that's how simply a dictionary is created. Similarly, in a programming, and this concept doesn't exist only in Python. This is there in Java. This is there in C Sharp. This should be there in C++ as well. Okay, that's a simple idea of dictionary. Dictionary has something like keys and values. Always make sure the key is unique. It is not unique in sense, not duplicate for key. But of course, values can be duplicated. So we don't have a problem with values, but keys must be unique. Unique means no duplicate. So the statement should be very clear for you. So that's the idea about dictionary, right? So that next one. Okay, leave about that. This is actually this we see this now when you start doing coding, every time you have to see this. So we don't, so you get a clear picture about it. That is fine now. Let's understand the characteristics of dictionary. So dictionary is mutable like list, okay, but it's not list here. This is not a linear data structure. This uses internally hashing. What is that? It internally uses something called, what shall I say? Something like hashing internally. So point one, point two is or point three is this is not a linear data structure like list, like tuple, like string. If you see all these linear data structures has something common. What is that? Can you answer that in the chat box? Again, a quick question to all of you. What is that question? Try to be little focused, friends, focused, and like to be little proactive. Please answer my questions as quick as possible. All linear data structures. I know this is a Sunday time. Some all that smells everything will be disturbing us. I know, friends. I'm just joking. Don't take it in other way. So, but I want you to smell this Python very much now. All linear data structures has something in common. What is that? Can you quickly answer this, friends? What is that in common here, friends? So one thing, of course, there are many things in common, but one very fundamental common among all this is thing. What, friends? What is the common this thing of not this one expression, condition, validation, parameters? That is fine. So what is that common thing here? What is that? Answer, friends. Please answer this. What it has common here? I'm just giving time so that you might think on this. Before, because that's how that gives you a clear difference between understanding dictionary and this linear data structures. What is that? Okay, heterogeneous data. Even we have heterogeneous data here. That is a different thing. But more than all this, one is very important. This is something real, something common between all this logic and process. No, let me just answer this. Okay, what is that? Indexing. So what is common among all linear data structures? Will you agree with me, friends? What is it? All the common thing among this is indexing. What is it, friends? Indexing. Is that clear? Indexing is common among all these linear data structures. Is that clear? But when it comes to the dictionary, we don't have indexing. So this is a big difference between this linear data structures and this non-linear. We can call this as non-linear data structures. What is this? This set, this dictionary, all these are non-linear data structures. What we can say, see here, these are non-linear actually. This dictionary, this set, all this. Okay. So indexing is the quite common thing among all these data structures. What is that? Among linear data structures, you say list, it has indexing, negative and positive indexing. You say tuple, it has indexing, negative and positive indexing. You say string, it has indexing, negative and positive indexing. In this way, if you see, we have all this indexing there. But for dictionary and set, they don't have indexing because these are not linear data structures, but these are. So when you talk about dictionary or set, okay, sorry. So these are non-linear data structures, non-linear, L-I-N-E-A-R, linear data structures or collections, you can say, STRUC structures. So these are all non-linear data structures. Means what, friends? Non-linear means they don't have indexing. So here for them, no indexing exists. Internally, it uses something called hashing. What is it uses? Internally, they uses something called hashing. Right. So that is a quick idea. Right. Next one. What are the other characteristics of Python here? So one is about dictionary here. What are all this? So it is mutable. That is one thing. So other characteristics of dictionary is it is a mutable. Mutable means what we can modify dictionary, so we don't have a problem there, friends. Understood now? So that is one thing. Second thing, order is not preserved. Of course, we don't talk. Order means like if it is list, what in whichever the order you enter elements, they stay in the same order. But here, when you add a key value pair, you cannot expect them to be preserved in the same order. You don't expect that they are there in the same order in which you insert them. Okay. So that's what we call order is not preserved. Got it right? So, and second thing, what? First thing is mutable. Mutable means you can modify dictionary, no problem. Like tuple, it's not immutable. Like you cannot, it's not like you cannot modify it. That is fine. Next. Second thing, it should be clear for you. It cannot, we don't preserve, this doesn't preserve order dictionary. And you can have heterogeneous data here as well. And here, the implementation of dictionary is in the form of what, friends? Is in the form of key and value pairs. What is it? It is in the form of key and value pairs. This is very important, very prominent feature of dictionary here, friends. Right? This is a quick idea. Understood now? And here in this dictionary, not only here, in any programming language, keys are unique. Unique means no duplicates. You cannot duplicate keys, but values can be duplicated. This is the quick idea here. Okay. So this should be clear for all of you. We got a lot of information on dictionary. We understood that what is this, how we came across two terminologies now, linear data structures, non-linear. Which are linear here means, so all these are linear. What is it? Your list is linear, your set, sorry, your tuple is linear, even string is linear, and bytes is linear, and byte array is linear. All these are linear data structures. Wherever you see indexing, they are all linear data structures. Okay. And we come across one more non-linear, that is this. What is this? This dictionary, this set, frozen set, like all these are non-linear data structures. Again, other characteristics are, is dictionary mutable or immutable? Mutable. Is insertion order is preserved in dictionary or not? Yes, insertion order is not preserved. Okay. Is it heterogeneous or homogeneous? It is heterogeneous. So what is other difference between this linear data structures and dictionary, especially dictionary? Dictionary is something really special. It has something called keys and values here in, and keys must be unique and values can be duplicated. Again, dictionaries are dynamic. What is it, friends? Dictionaries are dynamic. They are growable and shrinkable. What is it? They are growable and shrinkable in nature. Okay. If you add, you can add key value pair, you can remove key value pair from dictionary, and you can add how many other pairs you want. And this is most used data structure again, keep in mind. And generally, how do you build dictionaries? We build dictionaries with this processors, opening and closing processors. This is how we construct a dictionary. And you can see here, this is something like constructing empty dictionary here. This processor represents creating an empty dictionary. Is that clear? So this is simple idea how we construct dictionary, or otherwise we use a dict function to create a dictionary instead of this. There are two ways. One way is using this, what is this? This operator. So this is step approach one. Construct, how do we build, how do we create dictionaries means if you ask this question. So there are two ways. For all these collections, we create them in two ways, either with operator. For list, we use, we will come back to all this. We will summarize all that things. Okay. How do you create dictionary? Okay. We can create in two ways. Approach one, let's take it. Approach one. What is approach one here? Using operator. These are all operators. Building, creating this collection with operator using operator. We do the same for any all collections, not just only for dictionary. And this is how we create an empty dictionary. Suppose you just take this, copy this, and come to the code, and then what do you do? You just create a new file here. Otherwise, you say new uh, directory, and then say dictionary. Enter, and then right click again, add one file here, and then Python file, and then just demo. You can say dict fundamentals. Okay, this is our first program name. You can close this, friends. I think this is clear, right? First one. Let's add this, test this one. Now, what do you see? Print this D here, and if you want to know what is this type of D, type of D is what? This is an empty dictionary. We are building or constructing empty dictionary here. So we did that now. Now we are printing it, friends. Right click and just say run. And you can see here this class that is showing here is dict here. That itself shows that we created an empty dictionary. This is approach one. What is this approach one? We constructed dictionary by using, what is that? Using operator thing. Second approach. What is the second approach? Can you answer this, friends? Please give me, if possible, please try to answer approach two. What is approach two? Using what, friends? Using? Can you give me answer in the chat box? What is up? You are all of us know this. We right. All of us know this. What is it using? Please waiting for your answer, friends. Answer in the chat box. Using a built-in method. What is it? Of course, dict is fine. You give me a direct answer, Harish. More than that, simple, straightforward answer is using a built-in method that changes from collection to collection, built-in method, and this time using what is that? Dict method. Dict. So how do you create it? Something d2 equal to some dict. Okay, parenthesis, and then what? You can try again printing this and see the output. So print d2. Now even now you see the same class for the second approach. So approach two is what? Constructing a collection with some method. If it is a dictionary, we should apply dict method. Okay. Right click and run this now and see. You find same thing. This time even for second time, you can see a class dict is used internally to construct this dictionary here. Is that clear? Okay. So again, a quick quiz time for you again. Suppose if it is a list, just a quiz time, quick quiz time for all of you. Before I jump to the next topic, I know sometimes I'm breaking here. I'm trying to make sure that you get familiar with all these things in the on these collections. Question one: if it is listed, name, figure out. Okay, figure out what operator and what method we apply for list. Quick answer in the chat box, friends. If it is list, what operator we use to create list, or what method we use to create list? Please answer in the chat box, friends. Quick answer in the chat box. This is a quick quiz time. What operator and method? You have to answer two quick, this thing. For list, what operator we use, what method we use to construct list. Come on, friends. Please answer in the chat box. For list, for tuple, you can give another answer. Okay, we'll come one by one. Okay. Let's answer this. Okay, for list, I am asking. First question is on list. Maybe you can answer same for list as tuple as well. No? So let's see here. Let me summarize here. If it is list here, we use this one, this index operator, and then list method here. Okay. If it is tuple, what is the operator we use to construct tuple, and what is the method we use here? For tuple, we use this operator, this parenthesis, and then tuple method we use to construct this. Suppose if it is what else we discussed so far? Bytes and binary you can ignore, not needed. Right? That's it, friends. These two we had discussed so far among collections, and this is a quick idea. Operator is like this, and methods are like this. Okay. So this is a quick answer for these two. Okay, let's jump to the dictionary now. If it is dictionary again, if it is a dictionary, what method we use for dictionary and what operator we use? Operator is this. and method is dict here, friends. Okay, this is a quick idea. Is this clear for all of you? Right. Next, let's jump to the next topic here. So this is all about what is this, friends? Dictionary. Next one. Let us take a small example how to construct a simple dictionary here. Okay. So what else do we have here? So this is simple way of constructing dictionary. One way is applying this using one way is using this one parenthesis, not parenthesis, this braces. Second way is dict method. Okay. And then these are all other things. Now we don't need this immediately. So what do we do right now? We'll go one by one here. First now, what is first thing? Let's just how to create a simple dictionary here with key and value pairs. It looks like this, friends. A simple dictionary is like this. So here, let's do this now. Okay, let's do this. I think I'm trying to make you familiar with multiple things so that I'm trying asking these questions. Just start thinking. That's all, friends. No pressure here. Okay. Now, next one, simple example. Let's take a simple program. How to create a dictionary. You just say take some small data set. What is that? Some course dictionary course or something, anything of your choice. If not course, you can take some color dictionary. Okay. I'll take color dictionary, otherwise color underscore dict. Okay, and let's create few colors. One, and here usually how do we create key and value pairs? Simple, friends. The syntax of creating key value pair is your key should be like this. Syntax is simple syntax key colon value. So every key value pair should be created like this, friends. Key colon value. Key is something which identifies this value. Always we do manipulate, we do processing on dictionaries with the keys. Keys are important here. What is important, friends? Keys are important here. Understood, friends? So, of course, I don't say value is important. Of course, without value, what do you do, friends? It's not like that. But I'm just giving you an idea. So, whenever you manipulate dictionary, whenever you do any processing on dictionary, we do all that with keys, not with the values. First, once we get that value based on key, then later on again you do something on value again. Of course, that happens. But before that, the first focus point for us on in dictionary is key here. Okay. So now we are creating a color dictionary. And how do you create color? You can give this keys can be heterogeneous. It can be integers, it can be string, it can be double, or it can be anything of your choice. Okay. So now I'm just creating a small dictionary, one colon color, right? It should be in quotes. Okay. Color. So blue, you can give second two colon red. Okay. Something, any color you can provide three colon. So third one, three colon yellow. This is how we should create a simple dictionary. Yellow like this. This is a simple example. If you want, you can add one more. So fourth colon, some green. Okay. This is a simple way of creating a dictionary here. This is fine, right? So that's the idea. Now next one, color is done, right? So this is one example, friends. Okay. Next one. Similarly, if you want, you can create one more dictionary, right? Just I'm giving you a few examples how to construct a dictionary, friends. Okay. So this is one thing. Maybe if you ask me, Manoram, instead of this 1, 2, 3, 4, 5, can I give some other type of data? Yes, it's up to you. Suppose you take another example. This is one example. We'll continue on this only. But if you want, you can take multiple examples of dictionary. Like we can create one more, some text equal to test equal to open this. You can have key value pair like this one. Okay, something like uh, comma. You can say ABC. So or otherwise one colon one. You can see one colon some 100. Again two colon some 200. Something like this. Again three colon some 300. So you can see means what you can construct a dictionary with heterogeneous data. Your keys can be integer, your keys can be string, your keys can be double, your keys can be anything else, friends. Right? I think this is clear, right? And you can see values earlier, values are strings here, values are integers here. So this gives you a clear idea. What is it? We can create dictionary. We can declare this keys are heterogeneous, values are heterogeneous. Keys can be different type, values can be different type, or both can be same type. So this data set dictionary can be it can be heterogeneous as a finally, the conclusion is this can be heterogeneous. Is that clear? It's not like it should be only integers or it should be only string there. So this is a quick idea. Now, anyhow, I am removing this. Okay, just to show you that it's not like keys should be always integers and value should be string. I just took this second dictionary to show you that difference, like to make you understand better that these keys are heterogeneous and values are heterogeneous, both are heterogeneous. When you say heterogeneous, it can be of different types of data here. But for now, we are creating a small dictionary data set with a colors here. Okay. Now, how do you iterate it? Simply, one thing is you can directly say, what does it print? Print, and then print that dictionary directly. This is one way, right? So right click and then say run dictionary. You can see the output here. This is simple idea. Then you might ask multiple questions here. What is this? These are all multiple questions concerning with dictionary. One, Manoram, you are printing whole dictionary as is. We understood this. But suppose I want to iterate it and print. I want to iterate it and print one by one. This pair by pair. If you want to print pair by pair, what should we do now? That is one question. So printing in this printing pair by pair. Pair by pair means key value pair, like pair by pair. This is one scenario. Second, before that, iterating. First of all, doing a simple iteration on iterating. These are all collections, right? Generally, if something is a collection, you should always understand first how to iterate these collections. This is very important. Okay, iterating dictionaries. So how do you do that? Then printing pair by pair. And then printing only keys, another scenario. So I'm trying to give you make these fundamentals as simple as possible. Printing only keys, printing only values. Okay, so these are all simple use cases, friends. Printing only values. So this is not yet done. Okay, this because these are all very important concepts in Python. I'm trying to be very clear on this. So first thing, let us start with this one today. For today, iterating dictionary. How do you do? We know how to apply for some key some what is that you should get both key and value pair. We will come by one. We are going to play with this a lot and get a clear idea. Some key in what is that color dictionary colon and then some print of what is this key. Okay, I believe it will return keys here. Let's run it and see. Now for in the first case, we tried to print only we tried to print dictionary and we saw the output. Okay, this is fine. And before that, we understood very clearly how to build a simple dictionary with the keys and values here. This is how your dictionary look like. Which you should have a key associated with a value like this. Okay. Then we are iterating it. Now run this now. Run it. Now you can see here. You can see here by default when I say something like here some iteration here by default from the dictionary. What's happening? Your iterator is extracting only keys. What is it extracting? By default, it is extracting only keys. What is it extracting? Only keys, right? So that's what happened here. We got 1, 2, 3, 4. These are keys. Again, you ask a question. What is that question? Manoram, I want value also. It's not just keys. Where is the value? Then answer for that is what? There are multiple ways to bring values. So let's go one by one. First, so this is approach one. So case one. What is case one here? We created a dictionary, we printed, and when we observed the output. So we got output like this. This is case one. Okay, scenario one. Right. Otherwise, program one. Scenario two. What is scenario two? We understood how to simply iterate. What is that? Program to simply iterate a dictionary. Scenario three. Scenario three. What is scenario three? I'll just show you how to get value from a dictionary. I'm trying to be as simple as possible. Scenario 3, how to get a value from a dictionary. So how do you get a value from a dictionary? So there is a simple syntax here. What is it? That dictionary of key syntax for that is simple syntax is one such syntax is what, like how we extracted values from list by index. We extracted value from tuple by index. Okay, we extracted value from string by using index. You know, right? You know the syntax, right? Again, a quick. Again, I am asking. See, don't think I am distracting. Again, a quick quiz time because I want you to remember these things as much as possible. Okay, quiz time. What is it? How do you extract element from a list? Simply you say that a list of some index, right? You can simply say list of index, right, friends? Do you remember this? Right. Similarly, here also, if it is dictionary, that dictionary, this is your dictionary, color addict. Okay, copy that. Okay, no need of any this thing here. Color addict here, and then off, and then here inside this what as per syntax it would be like this. What is it? That dictionary open braces are this index, and inside this you have to pass key. And what this gives us, if you just try to pass something, dictionary name, of course, you can provide dictionary name. Let's have more meaningful syntax here. Dictionary name, and inside that dictionary, you should pass a key. Then you get a value. This is how we extract values from a dictionary. It's almost, it looks like more like getting a value from a list. But difference is for dictionary you pass key, for list you pass index. That is the difference. Okay, right. So this index is this is actually uh, built in. This comes from inside the this thing, this Python, this thing. This is actually a built-in one. Index is, but here keys are given by us. Okay, user defined ones. Okay. Now, this is the syntax to extract a value from a dictionary. This is a dictionary name, and then we should pass key here, right? So I want this color red. Then what should I do? Simply, I should say dictionary of two, and you have to print it. Okay, what is that? You should say print. Simply, you can apply a print. I'm using a simple format method this time. What is that? The color of a key. Okay, this one, some placeholder is again a placeholder. Close the codes dot format, and then what is that I should do? Open this one, and then you can pass the key of it. What is the key of that? The color of key is 2, so you can pass 2 directly, comma, and you can directly apply this syntax. How to get a value of certain key, the dictionary name of that key you pass, then you get the value. So this is simple print statement here. So I am trying to get it like this. Okay. So I hope this should be clear for you how to get a value from a dictionary using a key here. This is the syntax. Okay. And this is the example we are printing. We are trying to extract color. Okay. Based on key here and printing. Let's do this now. Let's run this and see observe the last output one by one. So here unexpected parsing, no problem. Close this one more time. So that will complete this one. Run it again. Okay, you can see here the color of key 2 is red here. This is so clear for us. Okay. Similarly, maybe you can try to extract color for 1, color for 3, color for 4. This is assignment, quick assignment for you. Testing time again. So again, this is what? This is a testing time for you. Come on, friends. What is testing time? Now you try to get our remaining colors from the dictionary. Get remaining colors from dictionary. You can try this. You can try this on your own at your, in your editor. Remaining colors from dictionary. This is testing time. Come on, do it, friends. Meanwhile, I will also do some testing. What is this? Let me try. I'm also very much interested to do this. This activity looks interesting for me. So I took 1 here and then passing 1 here. 2 is fine. Similarly, let me try for, what is it, friends? Let me try for 3. And then pass 3 here. And then let me try for 4. and then pass 4 here. See, now we are getting both key and value together, right? So let's run this and see. Color of key 1 is blue, key 2 is red, key 3 is yellow, key 3 is green, key 4 is green. Hope this is clear for all of you friends. This is again another scenario 3. How do you get a value from a dictionary based on a key here? This is the simple example. And maybe you can try. This is the quiz. This is actually the requirement for you. And also, this is a quick quiz time for you. Okay. I hope this is clear for all of you friends. Right. Please test it. Do it. To all these friends. So I hope these sessions are clear for you. This is one of the very good sessions we did so far. Maybe you can ask me, like, how do you know this is too good? Because that is the how we should be very clear, friends. I enjoyed this session a lot today. So definitely, this is one of our very good sessions and you very useful session as well. Hope did you did this testing right? Already I have given solution here, but I maybe from your side just do your testing, friends. If it is done, we will stop this session here, and then we'll get back again on in the next weekend. And don't miss these sessions, friends. Maybe thank you. Any questions you can ask me. Else we can close this session for today and catch up again next week. Wish you happy New Year for all of you. Have a good New Year and good weekend. Happy Sunday for all of you. Happy New Year. Happy Sunday. Wish you best of luck in the new year. Okay.